Good morning. We're going to continue on with some two-step inequalities. We're going to do, I think, two more examples here on inequalities. Remember, we have the less than symbol, the greater than symbol, the less than or equal to symbol, the greater than or equal to symbol. And remember, when we graph these on a number line, if it's a less than or greater than, we call those open-ended, which in other words we use what we call this open circle. Less than or equal to, greater than or equal to, we use what we call a closed-ended. We use a solid dot there to represent that solution's part of the answer. So let's look at this first inequality. So again, we see this fraction, and one of the things we learned with fractions is I can make that bottom number go away if I multiply by a top number, so I can divide it out. So what I'm going to do is multiply each side by 15 to make these 15s divide out. But remember, since this is like equation thinking, whatever you do to one side to keep it balanced, you have to do that same thing to the other side to keep everything staying true. So we learned that these 15s will go ahead and divide out. And then this brings down this a minus 9. And then we have the greater than, and 1 times 15 is 15. And since we didn't multiply or divide both sides by a negative number, that inequality sign stayed the same. Now to get a by itself, I just have to get rid of this negative 9, and I can use a 0 pair, add a 9 to both sides. The negative 9 and the positive 9 will 0 out. The a slides down, greater than, and then 15 plus 9 would be then 24. So our solution turns out that a has to be greater than 24 to make this play out correctly. So let's graph this on a number line. Since I got to go up to 24, I'm going to count by 6s. Because I know 6 is a multiple of 24 is a multiple of 6. So then I can go over here. So since we have to be greater than 24, we have to use an open circle at 24. So that's going to be my open circle. And greater than means I have to go to the right. And don't forget, this is like a little arrow. It's pointing to the right as well. It's telling me how to shade. So my solution would be everything to the right of 24. So that's including those decimals like 24.1 or 24.01. So anything that's just a hair to the right of 24 works, but 24 itself is not part of the solution. So let's look at this next example. I have to solve for r. Again, this is a two-step inequality. So we go after that negative 5 first, so we add a 5 to both sides. Let's see if I can find a better marker here. That one seems to be wearing out on me. So again, this 5 and negative 5 are going to 0 out, so I have a 3r. And I have a, actually, less than or equal to. And a negative 5 and a 5 becomes a 0. Now to get r by itself, I need to use division, since that's multiplication. The 3's divide out, r is less than or equal to, and 0 divided by 3 would be 0, because, if I put it, 0 times 3 does give me 0, so it does check out there. So 0 divided by 3 would indeed give me 0. So our solution would be then, any number less than or equal to 0 would satisfy this condition up here. So r has to be less than or equal to 0. So when I draw my solution on a number line, so we have to be less than or equal to 0. That means we use the closed-ended dot. So that means 0 is part of the solution. And I have to shade everything to the left of 0. So my solution would be everything to the left of 0. And again, I also saw a shade in that arrow to say that it keeps on going on and on forever. So any number that's less than or equal to 0 would satisfy this condition. Okay? So hopefully I'll help you continue to improve on two-step inequalities. Stay tuned for think we're getting into some word problem type stuff, so stay tuned.